Go. All right. So we are recording. All right. So again, this is a lesson that doesn't have a lot of math in it. It's math concepts, but it's not like you're solving for variables and doing a bunch of adding, subtracting, dividing, that kind of stuff. So for those of you that felt like you struggled with that piece in the beginning of the year, this is more taking good notes. If you don't understand something, ask questions so that we can clarify it for you. And then just doing the practice. The practice is, well, the practice and the notes is what's going to allow you to do well on that next quiz. So you have a quiz on Monday. So this will be on there. You know that it's every Monday. All right. So first of all, write down well, you don't have to write anything down, but just underline maybe x-intercept, y-intercept. Already in your pages. You have got to know for the next quiz mainly how to find an x-intercept and a y-intercept, but you kind of also need to understand a little bit about what they are. Finding it and understanding it. So I'll zoom in and I'll show you how to find them from a graph. Why is it not working? Son of a gun. Oh, I know why.
That's like two. That's like
You'll be in geometry or 11th grade.
that's a good. Because I know people who are freshmen in geometry right now. Yeah.
I say you. There are freshmen in. I have freshmen in my geometry class. All right, so here, this again is not a super tough concept, especially from a graph. Just make sure you keep it straight. If you have data on a graph, so remember the x-axis, the y-axis, that's not data. These grid lines are not data. That's just imaginary stuff that allows us to know where to put the data. X-axis is just a number line that goes horizontally. Y-axis is just a number line that goes up and down. So whenever I say data or the line or something like that, I'm talking about in the book, they're like blue, so it's easy to tell. But if you had a black and white graph, I'd be talking about the line or the points or whatever it was on there that is put on top of the grid lines. So if I have a graph and I ask you to find the y-intercept, super simple. Which one is the y-axis? You should already know it. What's the y-axis? Yeah, so first of all, the y-axis is the entire number line. It's not a point on the graph. The axis is the entire number line that goes up and down. How do we remember y is the one that goes up and down? Y to the sky, y goes high, whatever you want to rhyme, either of those two. So that's how you remember them. So if that's the y-axis, then you can just say, well, then the other one must be the x. So if I know that's the y-axis, if I know, okay, so the y-intercept is one single, well, actually it doesn't have to be a single, but it's anywhere where your line of data crosses over. Oh man. Yeah, it's off. I'm gonna have to try to fix that. So wherever your line of data crosses over the y-axis, that's the y-intercept. From a graph. It's a little trickier from other types of data, but that's all you have to do. Now, you sometimes will write that as just one number, -3. So when we get into creating equations, you're going to use this well, actually, you've already done this before in pre-algebra, but you're going to say b equals -3 for the y-intercept, because there was a variable we used when we did graphing a long time ago, and that we'll do again when we graph. And we said b is the variable for the y-intercept. We're not going to probably be doing it that way yet. We're going to be writing the ordered pair. What is the ordered pair for that? Michaela. What's the ordered pair for this red point? So the x and the y for that. Fantastic. 0, -3. Yeah. As long as you did 0 first, that was the main one. So remember to write an x and a y value for a point on a graph. That was the story I told you about the woman I almost married in the apartment complex. I had to go left or right first to get to the elevator. So if I'm starting here, I don't go left or right, which is why 0 is the first number for that. I didn't need to go left or right. I'm just going to wind up going down, which is the second number. So that's the ordered pair for that. Okay. So there will be something important about that later as well. So that is the y-intercept. That's all you got to be able to do from a graph is just see where the line crosses over the y-axis and be able to write the x and the y after that. Shouldn't be too terribly difficult. For the x-intercept, what do you think we do for the x-intercept? So what was the y-intercept? Daniel, what was the y-intercept? How do we describe what we're looking for in the y-intercept? What did I just do? What did I just do? Justin, what did I just do? The y-intercept. For the y-intercept, I just put a point where my line crossed the y-axis. So what do you think we're going to do for the x-intercept? Haley, what do I do for the x-intercept then? That you're drinking in my class.
Okay.
How do you find it? There's no way you can possibly communicate that. Look at what? That was right when you were drawing with your hand. So what's that called? X.
Fine.
No.
Why?
No, not Y. You look at the X. X-axis, yes. So you look at the X-axis and you just see where does your data cross the X-axis. Now, in this case, there's actually more than one X-intercept. So the X-intercept would be, I guess I'll use black. X, oh boy, that's going to be off. My board's jacked up. So there's actually 3 X-intercepts, which sometimes you'll have multiple intercepts, not always just one. If it's a curved line that goes back and forth, it might be one. If it's a dead straight line, then you'll only have one of each. So my X-intercepts would be those 3 points. We'll go with Katana. What is the X and Y value of this farthest left X-intercept? Farthest left. So we go left or right first. Where do we go? And we always start at 0, 0. So what's the first number then? So what's the first number? Count. 4. 4 was probably closer. But what side of the 0 are you on?
Oh, negative.
Negative. Remember, going left is negative, so your number part was right. Oh, and it's actually a little bit off. It's technically a little bit bigger than, or like it's really negative 4.1 or something like that, probably. But I'm fine with the negative. I'm not gonna say, but it was funny. It was pretty funny. Yeah. All right, so this point would be like negative, or if you can't see, it's technically not right. It's not right on the corner, so that's why it's negative 4 point something. So like maybe negative 4.1 and then comma 0. So that would be that point. God, my board is driving me. That would be that point right there. Again, make sure you remember to go left and right first. That's about the only thing you can really mess up on this type of question when you do the quiz. Just make sure you go left or right first to give me the first value. And then you go up or down. Well, we're not going up or down because we're right on that point already. That's why the second one is a 0. Let's go ahead. I'm going to do something that I didn't do in the other classes. What's the second point, Danielle? I'm going to call on you for this one. What is approximately, because again, this is a little bigger than, it's not right on the corner, but what would you guess is the ordered pair for that one? It wouldn't be 3 because we'd go 1, 2, so it'd be a little bit more than that. So like negative 2 point, you could say negative 2.1 again, maybe. What's the second value? 5. 0 again, right? We didn't go up or down again, right? Ladies, you need to pay attention. I'm making a point you need to know right now. So pay attention. Otherwise, you will find yourselves sitting in different spots. So we said this, where can I write this? I guess I'll write this one kind of up here. So negative 2 point, maybe 1 and 0 again. So, really wish, bless you. All right, and then what's the last one? I'll call on Gabriel. I'll call on Gabriel. So this one here that's also on the x-axis, what is that one about? You got to kind of estimate the first number. So it's actually not to 1. 1 is here, so it doesn't even make it to 1. I'd say 0.2 is good. What's the second value, the y value? It is 0. So this one is, again, it's 1 is here, so we don't even make it to 1. So it's about 0.2 comma 0. So those are all x-intercepts. Those are all x-intercepts. Now here's the question I have for somebody that's super smart person. Sophia, super smart person. What do those 3 x-intercepts have in common that I just wrote? You don't even really have to understand. You can just look at what I wrote. What do they have in common? Look at them. What do they all have in common? Kind of wrote it really dark on a couple of them.
Oh.
How can you? What did I write really dark in the first 2 points? The first 2 ordered pair. They all have 0 as the y, right? I had a 0 as the y right here. I had a 0 as the y right here. I had a 0 as the y right here. Here's your next note. First of all, just every intercept. Don't worry about x and y yet. So write this one first. Every intercept, if it's crossing over one of the 2 axes, so if it's crossing over the x or the y, definitely crossing them somewhere, they're going to have a 0 in the ordered pair. They have to because, okay, so now I'm going to get rid of everything so we can. I'll say it again. Oh boy. Oh, let me do it on. There would be no way to do that without doing it. So look at where the x-axis is. Like the x-axis goes through what number on the y-axis? Where does the x-axis go through on the y-axis? Now you get one stuff.
Hold on, say it again.
So this is the x-axis, right? Where does that go through the y-axis? Where does that meet the y-axis? Look, count on the y-axis. Where are your numbers at? The x-axis is down here. You count it up. This is the x-axis here.
I don't know.
Where does that go through?
Where the y-axis goes.
No, where does this line here? Oh, I can't. My board's off. I can't remember. Nope. Look at where they connect. Where do they connect? What's the number for y? No. Yes. No.
You said 0.
Oh, I didn't hear you say
You
0.
said 0. You were like, no.
Oh, I didn't hear you say 0. So yeah, the x-axis goes through the y. Again, these are just number lines, remember? Oh, let me try to fix it so I can actually show this. Hopefully this works. If not, I don't really know how I'm going to show it.
do?
What'd you say?
What do you have to do is so perfect.
Well, if you do it fast, it doesn't help. The reason I think that it messes up is because it's slow and it's not registering and something. So I have to, well, I don't really control actually, this is a pretty good. Now let's try this. There. So that's the x-axis right there.
It's 0.
Well, I'm showing everything. So all right, so tune back in, ladies, gentlemen, please. That's the x-axis. You're confused. Again, it's just the number line that goes through the y-axis at 0. Here's 3, 2, 1, 0. Then -1, -2, -3, and it keeps going down. So the x-axis goes through y at 0. Well, if I'm going to be going through y at 0, anytime I have a line that touches that, the y value has to be 0. It will always be 0. Every x-intercept will have a y value of 0. It has to. That's the definition. It's touching the x-axis. So let me ask you this question. This is my y-intercept. That's where I'm touching the y-axis. What's the x value going to be? X value. Y is -3. What's the x value right here? 0. Isn't that where the y-axis is going through? Always. It's always 0. So the x value, so anytime I cross through the y-axis, so if I drew another line, do it on a different screen where I can show you more stuff. Yeah. Oh. Here, I think we can do it on this one. Hold on. And then I can draw more stuff and show you. I didn't really want that. Hold on, let me see if I can find one with less stuff on it. I'd like to have a line on it, but all right, here, we can use this one. My videos? Depends. Depends on what happens. Sometimes I forget to stop them, so I definitely have to edit those because then they're like twice as long as they should. What'd you say? I don't know. Well, trust me, there are people that have way more YouTube stuff on there than I have. Wait, like think about people that are like trying to make a living on YouTube or something. All right, so if I put a line on that graph, so there's a line on the graph, right? That line has an x and y intercept. That's fine. Logan, Haley. Oh, I didn't hear your voice. So if that is my line on the graph, my y-intercept, that's as zoomed in as it gets, unfortunately. But again, you know where the x-axis is, you know where the y-axis is. If I cross through right there, that's where I'm touching the x-axis, right? The y value, again, count down. It's got the number 7, 6, 5, 4, 3, 2, 1, 0. It's going to be 0. I can draw another line in there. Do it in red, maybe? Oh, that's well, that's fine. So I draw a line through here. There, I fixed it though. So again, I crossed the x-axis right there. Well, what's the y value? It's 0. It's got to be 0. The x-axis is on 0. The y, well, again, if it's an x-intercept, so if I'm crossing the x-axis, because that's an x-intercept, the y value has to be 0 because that's where I'm at on the y number line. This line is always going through 0. So the y value is always 0. If you don't get it visually, then you just need to remember for an x, so write this down because you're not getting it. The y value for an x-intercept is always 0. You have to remember it, remember it. You can picture it on a graph though. Every time I touch the x-axis, which is the definition of an x-intercept, I'm touching the x-axis. Every time I touch it, I have to be at a y value of 0. That's where the x-axis is. It's at 0. No, it would still touch it. It'd still be 0. You'll just do it twice. It'll hit it twice. Oh, then you wouldn't have an x-intercept. Then you wouldn't have it. If you have an x-intercept, if you touch it, y has to be 0. So if you don't have it, now sometimes you won't have, that's actually a good point. Sometimes you don't have an x-intercept or a y-intercept. If you have a curved line, if you have a straight line, you'll always have one of each. Let's draw one more line and then we'll just draw it. Oh, I don't know why that didn't make it blue, but it didn't. And there. Blue. So again, that line, oh, I don't want to put it there. So that line, oh. There. So that line crosses the x-axis, like really it's like -6.5. But the y value is 0. It has to be 0 because you'll never go up or down. Remember, you go left or right first, then go up or down. Well, if I'm already on the x-axis, I'll never have to go up or down. I'm already on the x-axis. So if we're not going up or down for the second number. So here's 1, there's 1, there's 1. You will never go up or down for your second number because you're already at your point. You'll only go left or right. So you'll only have a first number. So therefore the y value is always 0. The next intercept. So the opposite is true. So now write the opposite thing basically for the y-intercept. For the y-intercept, I will never go left or right because I'm always going to be going to a point that's on the y-axis. That's the definition of y-intercept. I'm touching the y-axis. So I'll never have to go left or right. So the first number is always 0. So this point here would be 0, 4. This would be 0, 2.5 or something like that. This would be 0, -2. So your first number is always 0. Your x value will always be 0. Because remember, if I'm on, again, definition, if I'm touching this y-axis, which is the definition of a y-intercept, I'm touching the y-axis. Well, if I'm touching that, I never have to go left or right to get to the point I'm going to. So the first number is always 0. Never have to go left or right. You just go up or down for your second. Well, if you paid more attention, it probably would.
I really am. I just don't know.
Well, now you
But it's graphing to me. I would.
then you're in trouble because the next lesson is about 2 or 3 weeks of graphing. So we skipped it. Normally we do it before this, but we're kind of starting to get into it. This is sort of your intro into it. Again, if you have to remember it, just remember for an x-intercept, then the y is always 0. For a y-intercept, the x is always 0. If you have to remember it, or if you have to memorize it, memorize it. Because here's what's going to happen. Here's your next step. It's easy, or at least I hope it's easy, to pick out the x-intercept or the y-intercept from a graph. You just see where does it cross the x-axis or the y-axis. I'm, however, going to give you other questions. I'll show you. That's not neat. You will eventually get to those, but I'll do an easier one now. Find one. Oh. And oh, let's zoom out. I can't see anything. Got to be a table or a set of ordered pairs or something. No, still no. Still no. Drawing still there. Oh, wow. All right, so here we go. So if I give you this table right here, actually any of these. Well, no. So I gave you those tables and I say, What's the y-intercept in 10 and 11? Yeah, I want to know the y-intercept. So I didn't give you a graph. Which one? For 10? It is. It's 3. You don't need a graph. I just told you wherever x is 0, basically, like if x is 0, which it is right there, that's your y-intercept. So no graph, you're still going to have to be able to pull the x or the y-intercept from a table or from a set of ordered pairs. It could be a bunch of ordered pairs like down here. So in number 13, if I said, what is the y-intercept? What is it? Yeah, wherever x is 0. If I said, I don't see any of these. I kind of do, but technically that wouldn't really. Well, no, that would work. 16. What if I said, what is the x-intercept? The x-intercept would be this one, where the y is 0. So that's where we're going to on your quiz, is you're going to have ordered pairs. It is the opposite. Whatever you got to do to remember it. If you're not able to get the concept, then you've got to come up with your own like kind of memory trick to be able to get the intercept. That is already made your quiz up for next month. That is 2 questions on your quiz. You know, tell me x-intercept lines. And it may not necessarily be from a graph. So it could be from a set of ordered pairs, from a table, or from a graph that I asked you to tell me. Okay, so now we got to do linear and nonlinear. Wait, we do linear and nonlinear the last time? We do that like a straight line versus a curved line. All you're really looking for is the exponent of 2 or higher.
Yeah.
Let me go to the book to see where we're actually at. Oh, there is one thing. I should have said this. When I said about what you're looking for is an exponent of 2 or higher, I forgot to tell this to yesterday's classes. That's for this class. So when you get to next year, there are other situations where you may not see an exponent of 2 or higher, and it could still be a curved line. For this class, though, I'm not giving you any of those more challenging situations where you kind of have to figure it out. For this class, it's either going to be a linear, a straight line, which means there's no exponent of 2 or higher, or it's going to be a curved line if you see an exponent of 2 or higher. But just remember, when you see that next year, and don't say, "Oh, Mr. Gill said this." What I'm telling you is for this class. And I don't, frankly, I don't even know if it'll get that difficult next year in algebra, but it is possible to have an equation that doesn't have an exponent of 2 or higher, but is still a curved line. Not just yes. We're in here for a long time. We got 45 more minutes in here. I know, so exciting. So let me get through the lesson, and then you guys will have practice time, and you can do it during your practice time. So we talked about any questions in on x and y intercept? That is, like I said, at least 2 questions. I can't remember if it was more than that or not. And I don't even remember if it was from a graph or from ordered pairs or whatever, but eventually you will have ordered pairs on there. Yes.
Can I go back?
Yes. So I need to clear this. All right. So where's my red? So intercepts we did now. Linear function. So go ahead and do the first 2 parts of question. What is that? Oh, thank you. First 2 parts of question, example 1, excuse me. So just where it says x and y intercept. Do those now. The page is always, the first number, 89. So you should be able to give me the x and y intercept for that straight line on your graph. 89. Example 1. Example 1. Just the first 2. Just the first 2 examples. You can do the second piece.
This one, it's going to both the x.
Well, one's the x and one's the y.
That one's 0.
Yeah, so you have an x-intercept and a y-intercept.
Why would it be?
Y-intercept.
Yeah, which one would you? First, the first one.
Just put an ordered pair, like just what ordered pair goes where it touches? Like write down what is the ordered pair, what's the x and the y value for that point, and you'll see where the 0. So they do the x-intercept.
That just goes like the opposite. So this x-axis is higher.
I mean, you know how to put a point on a graph. This shouldn't be real. I'm like how to either put a point on a graph or like just label the point if you have to. If you're confused about the whole, like x is intercept has a 0, y, like just put a point on the graph. So there's the point where they touch. What's the x and the y value for that? Well, I go left or right first. Well, if I don't need to go left or right, then it's a 0. Then I go up. How do you know which one is 0? So the y-intercept crosses the y-axis. Always. And then do that same thing for the one that crosses down below.
Yeah.
It'll be 0.
Y is between. 1, 2. Yeah, that's all you is
No.
Yeah, I'll tell you what. My class is what it is. If I approve or not. All right, so what's the other one then? So that was the y-intercept actually. That was actually the second 2 boxes. What was the first one? 3, 0, right? Again, if you just know how to put a point on a graph, just label that point where they cross. I go left or right first to get to the elevator. You remember the story? Well, that means I go right. So my first number is 3. Then I go up or down. Well, I don't need to go up or down because I'm already on the dot. So that's a 0. So go ahead and fill in the answers. Totally did that backwards. I realized it halfway through and I still kept doing it. So x was first, right? So 3, 0, 0, 6. All right, let me do this next piece and then you can start the line. So here's what it will probably be the most difficult thing on the quiz, I think. Maybe there's other stuff. It's going to talk about when a graph is positive or negative, or a function is positive or negative. I'm still missing one. Ta-da! No, these aren't them. Just I had to bring more in. So, if a graph is positive, that means your output is positive. If a graph is net, so write this down because I don't think this is in the pages. Not the way I'm saying it. If it's asking you down here, or I'm sorry, if a function is positive, I should say. If a function is positive, it's asking you where is the output positive. I'll explain that more. You write another note around that so leave a little. It's asking you where is the output positive. And you're going to add a little more to that, so leave a little room. If a function is negative, it's asking you where is the output negative. So write that first. If a function is positive, it's asking you where is the output positive. If a function is, if they're asking you where is the function negative, it's asking you where is the output negative. So the function being negative or positive is tied to the output being negative or positive. And we're going to add some to that. So if you don't understand that, that's fine. We're going to add more to it. It's really, you wrote the same thing twice, just you changed. You changed positive for the word negative. Should have the same thing. No, I can't say anything. Dude, you just now pulling a pencil now.
They're not sparing us. Ask for that.
Why don't you need a pencil? There's like a whole drawer full of pencils. I know. I'll get with you in the independent. So Here's what did we say the output was when you first started functions? One thing was input, one thing was output. X was what? No, X is not output. X is input, Y is output. So what they're asking you for, is where is the Y value positive or where is the Y value negative? So if we want to do the positive part, here's where the Y value is positive. Anywhere through there. And remember, that line continues to go on forever to the left. Never stops. Go on forever to the left. If it's asking you where it is negative, it would be from here down, right? Because it'll go on forever straight down. So that'll always be negative outputs, ever going to the right. So now here's the last piece that you have to understand, and this is the tougher piece. You write the answer. If you want to know when the function is positive, it's asking you for what input value, what X values is the line red, basically. Is it above the X axis? What are the X values? Like name some of them where that red line is. Give me an X value that matches up with that red line. Any X value. Well, just the X value. So 4, let's talk about that. 4, 1 would be right here, right? Is this output in the positive area if I go all the way out to 4? Is it? This is the output. This is the output. If I'm at 4, my output is not positive. So 4 is not in the positive area. Give me another one. So 3, that's a good question. Am I positive at 3? Number am I at? Is that a positive number? 0 is not positive or negative. So that's an important point that you just made. We're going to come back to it anyway, but 0 is neither, so you may need to write this down. 0 is neither positive or negative. So you cannot include 0. Not include the value of 0. The point where 0 is. And I'll show you how you take that into account. That will be kind of the last thing. So give me another X value. Now for 2, I am in the positive. I'm right here. My output is positive. I'm right there, right? So for 2, yeah, that works. What other number? And couldn't we along those lines pretty much just keep going left forever? Like any number for the X-axis where we keep going left, that line's eventually going to get there because it goes on forever. So here's the way you write that. If X needs to be, or I'm sorry, if you want to know where the function is positive, X, so your value, it's always based on your value of X. Always, always, always. You'll always write X first there. X has to be less than the number 3. It cannot be equal to 3 because then we're on 0 and we said 0 is not positive or negative. So X has to be less than 3 because anytime I am left of this number, my output, my line is red, basically. I'm in the positive area of the graph. Anytime I'm left of that number where X is 3. So X has to be less than 3. Now I want you to try to do the other part, the negative part. Now that I've done that one. So the next one says, where is the function negative? Right concept, but you need to be a little more detailed. There's some other stuff. Anybody think they know? 4 is a correct answer, but what did I write for? 5 would also be a correct answer, but there are some other ones you're missing by starting at 4. Wish I could zoom. Oh, wait, can you? I don't know. That's fine. Oh, I can't. Good. So Kitana said at 4. At 4, I would be in the negative, right? At 5, I would be in the negative. All of these, you're right. I'd be in the negative at all of these. So all of those X's work. But what are you missing? What do you mean by first number? Because she's saying 4 is the first number. She's saying we start at 4, right? By 3. 3 is the correct answer where we start again. Why do we start at 3 again? It's the 0, right? Any number lower than 0 is negative. So when you start at 4, you're missing all of this down here. You're missing all of this. These are negative numbers. I can't forget about that part of the graph. That's negative. So you have to use 3 again. You'll always use the same number. Because this is like the middle. That's like the point where you go positive or negative, right? Don't forget there are decimals. You're forgetting about decimals. 3, if x is 3.1, then my graph is negative. If it's 3.2, my graph is negative. 3.3, 3.4. So the value where x is 0, basically. So at this point right here, it's always that number you use. In one case, is you're just going to say x is less than that number. In the other case, you're going to say x is greater than. And it's not always going to be in the same order. Sometimes the graph may be positive where x is less than a number, but negative where it's greater. You're going to practice it, so if you're still confused. But I told you this was going to be the hardest thing on the quiz, is figuring this one out. So practice this if you think you're good on everything else. So the answer would be, just so you have them filled in. Nah, this is the hardest thing I said on. Wait, how do I get off screen at the same time? I can't, apparently. So here, I'll rewrite it. So for these two problems, x would have to be less than 3 in order for the graph to be positive. X would have to be greater than 3 in order for it to be negative for that particular line. Yeah, because it's the x values. We're talking about the input values, right? The x is going left or the x's are going right. The output is just, you're just looking to see where the output is above or below the x-axis. That's what you're looking for as far as the output. But it doesn't, you don't say anything in the answer. Well, anything in the positive part of the graph. So the positive part of the graph is the top part. So in this case, the line is above it going left. Sometimes though, we might get, well, you will get, I'll just show you real quick because you're going to do this on your own. If I had a line that went like this, so that red line, well, now the positive part of the graph is greater than x and the negative part is left of x. I don't think it's always, like, it's not always one way. Sometimes it's going to be this way, sometimes it's going to be a reverse, where it's positive when x is greater than negative 1.5 or whatever. So you need to practice. Apparently a lot of people need to practice this part of it. I think, is that the last thing we do? I mean, you got to practice, but I think there's any more new stuff. I think so. That's the same thing. Intercepts. Intercepts again. Intercepts from a table. Oh, so what's the intercept real quick there? The what's the y-intercept from that table? What's the y-intercept? Oh man, how did my what's the y-intercept from that table? Well, balance is the y values, but what's the y-intercept? Y-intercept is where x equals 0. It's where x is 0, so 150 is the y. Again, if you've got to know that, that's on the quiz. Along with, you know, you're already struggling with that positive and negative thing. So if you know you're going to be missing that one, Gabrielle, phone up. You know you're going to miss that one. You better make sure you're good at all the other ones. Right now, some of you are still struggling. When I give you a table or a set of ordered pairs, you're still struggling to figure out where the x-intercept is from that. Because you're about to practice it and learn it even more. You have time for me to answer questions and for you to figure it out. Really, I mean, it's not, girl, it's not super difficult. You got a 0. I'm not saying it's easy, but if you practice it, you're not doing any math. Looking, okay, where is x 0? Well, then the y is the y-intercept. Where is y 0? Well, then the x is the x-intercept. Only one page. It's not like huge. It's, you have to know if something is linear or non-linear. That's pretty easy. Is it a straight line or not? Is there an exponent of 2 or higher or not? I mean, that's not too difficult. You have to know, is it discrete or continuous? That's pretty easy. Is it a bunch of points on a graph? Is it a solid continuous line, or is it neither? That's pretty easy. And then now you have to know, where is the graph positive or negative?